QuickCMC allows you to manually conduct different tests without having to pre-configure an automatic test plan. It is the ideal starting point for new users of the Test Universe software. QuickCMC is easy to use, powerful, and at the same time allows the user flexibility to test a wide range of devices, including overcurrent, differential, and distance relays. It can also be applied to testing transducers and meters. QuickCMC can be seen as a virtual front panel control. Voltage and current outputs can be defined statically in magnitude, phase, and frequency, which, for example, is good for testing overcurrent trip times. In addition, these signals can be set to ramp up or down, checking pickup drop-off settings, or even over/under voltage settings. Parameter settings, such as trip times, can be measured using the CMC binary inputs, and feedback signals can be created using the binary outputs. Omicron's Ohm's law, relating to object, hardware, and module, is a guide to follow for creating new tests easily. First, open the test object function to configure the relay under test and complete the entry fields on the Device Settings tab. Our relay is located in a 110 kV network at 50 Hz. The voltage transformer ratio is 110 kV to 100 volts, and the current transformer ratio is 600 to 1. The relay can withstand a maximum continuous current of 4 amps. The overload sensitivity is set to high for digital relays. We apply the default values for the filter function. You may wonder why QuickCMC contains a distance block when it is not a dedicated module for this specific protection function. This is because QuickCMC can use parts of the distance test object, like the impedance diagram or line angle, while testing distance protection. Now we can export this configuration for future applications. The second step to the Ohm's Law guide is the hardware configuration, where you define the hardware inputs and outputs you want to use for testing. In our example, we define a generic configuration with 3 voltages and 3 currents. We will assign the start and trip contacts to binary inputs 1 and 2. The last step will be the configuration of the module itself. QuickCMC is divided into several windows which are accessible via the View tab. In the Test view, specify all required test parameters. It is also split into different sections. The Analog Outputs drop-down menu offers a variety of fault modes to choose from. The default option is the direct mode, as it is the most common and simplest way to test with QuickCMC. Using direct mode, you can control the voltage and current generators by setting the amplitude, phase, and frequency of each generator. Define the settings by clicking on the field you want to edit and enter the desired value. On right-clicking the mouse, you can choose from a range of commonly used values from the context menu. This allows for a fast and convenient configuration of your tests. A typical application is to perform a wiring check by injecting some values of voltage and current using the direct mode. By observing these values on your relay's display, you can effectively check that the wiring has been connected correctly. The test view also includes a phasor diagram that displays the values entered in the analog outputs table. However, you can also set the values here by dragging the vectors. The binary outputs are activated by selecting the corresponding checkbox. To activate any of the 8 binary outputs, they must have been previously enabled in the hardware configuration. Otherwise, they are grayed out, as seen with binary outputs 5 to 8. The Home tab is the main view for controlling and running a test. To start a test, the Start button should be activated and all defined output values will be injected into the test object. The test execution can be stopped automatically in the event of a defined trigger condition, such as a binary input trip command. If you want to start your test with a pre-fault condition, click on the pre-fault button. This will generate a healthy network condition of 3-phase nominal voltage. There is an option to hold the test outputs at their set value by pressing the Hold Values button. While this button is enabled, the CMC output values are held while new output settings can be set on the Analog Outputs table. Releasing the Hold Values button will then inject the new values into the test object. This is useful, for example, if you want to switch from a healthy network condition to a 2-phase or 3-phase fault. The Analog Inputs section displays the measurements of the transducer inputs. The Binary Inputs and Trigger section displays the status of the binary inputs to the CMC test set. The number of available binary inputs is defined in the hardware configuration. The LED icons display the operating state of the 10 binary inputs. Red indicates that the binary input is active. Each individual binary input can be defined as a trigger by activating the checkbox. The trigger determines which binary input starts the timing measurements. Once the trigger occurs, the binary inputs and trigger box display the slope of the signal change, rising or falling edge, and the time that elapses between the latest change at any of the CMC outputs and the state transition of the binary input. Selecting Switch Off turns off the CMC analog outputs the moment a trigger signal occurs at the binary input. Since QuickCMC does not do any automatic assessment, it is necessary to click on the Add to Report button to transfer the settings and results to the report. Click on the Report view to access the report containing all tests. Any change in the test object or hardware configuration is not allowed unless all results are cleared first.